Hi students, we're going to talk now about vectors in three-dimensional. First of all, you all recall that a vector is characterized by its sense. Like here, all they have the same sense. If one is up, one is down, opposite sense. Its direction, if they are parallel or not, and its norm, its distance. As you can see in the third one, these two vectors, they have the same sense, same direction, and same norm. So we say that these two vectors are equal. So if you join the extremities, you can form a parallelogram. Equal vectors are called also equivalent vector. You can have here you can have infinitely many equivalent vector to a vector. You just pick a starting point, you draw a parallel and same sense and same measure, same norm. You may have equivalent here, you can have equivalent here, etc. Infinity of equivalent vectors. If you want to talk about norm, you put absolute value. It means the distance of the vector, and always norm, it has a specific formula. We're going to talk about it now. First of all, every vector has x. If you have two-dimensional, you have two coordinates. If you have a three, you have x, y, z. And if you want to write it in scalar component form, you say here it's v1 times I, where I is the unit vector of the x-axis, plus v2 j, where j is the unit vector of the y-axis, and v3 k. So here we say we're going to write it in scalar component form, where I, j, k are the unit of the x, y, z axis. And if you want to find the norm, so like we did in two-dimensional, it's square root of the sum of square of each component. Okay, and if you have 2 points, so you do x2 minus x1 squared plus y2 minus y1 squared. We're going to see, for example, in the examples later on. So first of all, here I have find the component form and the length of the vector with the initial. Here you have 2 points. You can put it on the x and y, z axis. But if you want to find, first of all, the components, you must find the coordinates. If you want to find the coordinates of P and Q, so what do? It's very simple. We do xq minus xp, so minus 5 plus 3, so it will be minus 2. For the y, you do 2 minus 4 is minus 2 also. And for the z, you do 2 minus 1, which is 1. So if you want to write it in scalar components form, you say it's minus 2i, vector I, for the x-axis, minus 2j for the y-axis, plus 1k or k. And if you want to find, like we did it here, if you want to find the norm, what do? You do square absolute value of v of this square plus this square plus this square. You're going to get 4 plus 4 plus 1, which is root 9, is equal to 3. So directly, if you have a vector v whose components are, for example, 1, 2, 3, if you want to find its norm, for example, you do square root of 1 square plus 2 square plus 3 square plus 9. But if you have 2 points, you must find first of all the components of the vector, like we did here, xq minus xp, yq minus yp, zq minus zp, z of terminal point minus z of the first point, for example, and then you square the answers. However, in this example here, if you have 2 points, you can write it this way, or you can do it before, and then you do root v1 squared plus v2 squared plus v3 squared. Depends on what things you want to do. First of all, I'm going to start here by graphing vectors in 3 dimensions. Suppose I told you graph vector AB, I gave you A and B. So as you know, graphing points in 3 dimensional, X is 1, this is X, Y is 3, this is Y. You do the parallelogram, you do the diagonal, you go to the elevation 2, parallel to the diagonal, you have point A. And similarly, here you're going to get point B if you do. You can check it by yourself. And then you join vector A to B. Here I have only one unique vector because I want vector starting the starting point A and the terminal point is B. However, in the second one, I have a vector 2, minus 2, 4. So you can start by the origin. What do? I want it as a vector. I don't have 2 points. So directly I want it as a vector. You start, you take x2, y minus 2, you join it. So now I do this diagonal, which is a vector diagonal now, different than this one. Then you go to the elevation 4. You do parallel to the diagonal, and then you join it. So this will be the end point of the vector. This is the starting point of the vector. So you join it. So this will be a vector. No need, for example, this vector v always to start by the origin. You can pick any point here, do parallel to it, same direction. You have another equivalent vector. This vector v, and this is also v, because they are parallel. Same direction and same sense. Here the same, you can have another one. You have billions of vectors. Let us go to GeoGebra for a while to tell you how to graph vector. So 3D graphic. Suppose I want, for example, a vector v whose components 1, 2, 3. So you put the small v, not big V. So this is vector v, as you can see. You may have infinitely many vector anywhere you can take it, for example. And if you have, for example, point A, you can put point A whose components 1, 2, 3, for example. Let me change it 4. Point B minus 1, 2, 3. And if you want vector starting by point A, ending at point B, you're going to get that vector. Okay, so using GeoGebra, you can it will graph for you the vector you want. Okay, so let us continue now. Here, addition of two vectors, if they start from the same point, I want to pay attention here. And the two vectors going from the point towards outside, like here, if you want to find the vector sum of u plus v, you continue the parallelogram, it will be the biggest diagonal. So for any time you have, for example, if you have a vector u plus vector v, and both are going out from this point towards out, you continue the parallelogram and you draw a parallel here and the parallel here, it will be this resulting force of the parallelogram. Concerning this one, and I advise you, if anytime, if you don't have this way, if you have, for example, vector u plus vector v like here, you can pick any point you want anywhere. You do a parallel equivalent to that vector. And then from this point also, parallel to that vector. Now you have that case. Now if you continue the parallelogram, as we said, you're going to get the resulting vector, which is this one. As you can see, you can then draw it here. So we're going to see by graphing now vectors. I gave you an example. This is the given. I gave you 3 vectors, u, v, w. I want to find, first of all, u plus 2v. So let us start. This is the given. This is u, v, w. You can pick anywhere the point. Here I pick this point to be u. So I draw a parallel to u, same sense, same direction, as you can see. I want it plus 2v. So parallel to 2v, but double the distance. Suppose this is the v, this is double v. Because now I'm starting from this same point, so I continue the parallelogram. This will be u plus 2v. You can have it anywhere you want. For example, I can graph it here. This is u plus 2v. I can graph it from the origin. So this is the answer of vector u plus v. This is the answer. Okay. Another example. Now I want vector minus u plus v. If this is u, I started from now from here this point. If this is u, I do parallel but opposite sense, because if you begin going up minus u going down plus v, you do draw a parallel because going out, so it's resulting of the parallelogram if you continue. So this will be resulting. You can start another one from, you do a parallel to it from the origin, or you can do it in any point. So this is a third one here. The most important is to draw any equivalent vector. You can keep it as it is, or you can do it as from the origin. Another one, if you want 2u minus v, this is u, this is minus this is 2u, double parallel. If this is if this is v going down, minus v will be from this point going up. So continue parallelogram. So this will be the resulting vector. You can do it from the origin, or you can keep it from here. It's up to you to decide. All are correct. In choice D, I want u plus v plus 2w. First of all, I want to do u plus v. So I draw a parallel to u, a parallel to v. I do the resulting by doing the parallelogram. Now I have u plus v. So this is u plus v. So I take another point. I do u plus v. Then I want to w. If this is w, I do double of it, parallel same direction. I do another resulting. So this will be u plus v plus 2w, as you can see. You can do it from the origin, or you can keep it. What is a unit vector? You know, in the unit of centimeter is 1 centimeter. The unit of kilometer is 1 kilometer. The unit of a trigonometric circle is a circle whose radius is 1. Unit vector, I mean, suppose you have a vector, for example, v. I want to find a vector parallel to v, same direction to v, but whose norm is 1. So this will be the unit vector of v. So this will be unit vector of v. And unit vector of v is denoted by v over its norm. Why v over its norm? When we say v vector, it means parallel to v, same sense. When you divide it by its norm, so if you do the norm for all of this one, you're going to get norm of v over norm of v. This is norm of v over norm of v, which is norm of v over norm of v is 1. So it means it's 1 unit. So the unit of a vector v, like we did, well, like we said, in the unit in kilometer is 1 kilometer, always one something. The unit of norm v is 1 norm of v, where it has parallel to v, same direction to v, but whose length is 1. So this is by definition norm, or the unit vector of v. So you need to memorize it's a v over its norm. And if I want to write v, a vector v, as a product of its length, you know the length is the norm, and its direction in a parallel to it and the same sense, it will be norm of v times v over its norm. So if you cancel v and v norm, you're going to get vector v equal vector v. So if they ask you about unit vector of a vector, you just do v over its norm. And if they ask you to write v as a product of its length and its direction, or its norm and its direction, you do its norm of v times v over norm of v. So we're going to see these in application problem. Okay, now the application problem, I'm going to start by the first one. You have this given. Number 1, write in scalar components vector AB, then u minus 2cb. So I'm going to start by vector AB. As we said before, it's xb minus xa, yb minus ya, zb minus za. So I start 5 minus 2 is 7, 2 minus 3 is minus 1, minus 2 minus 1 is minus 3. So if I want to write it in scalar components, what do I do? So it will be 7i minus j minus 3k. And for the one u minus 2cb, first of all, I'm going to find cb. So xb minus xc, yb minus yc, zb minus zc. So you have 5 minus 1 is 4, 2 plus minus 1 is a 3, and minus 2 minus 2 is minus 4. So you have vector u, this is vector u, minus 5 to 3, minus 2 into vector what? CB. CB is, as we said, 4, 3 minus 4. So we multiply here by minus 2, and instead you put the plus. You're going to get minus 8, minus 6, and 8. If you add minus 5 to minus 8, minus 13, you add x to x. y to y, z to z, you're going to get minus 13, minus 4, and 11. And if you want to write it in scalar component, you're going to get minus 13i minus 4j plus 11k. So I'm going to see you in the second video in a while, where I'm going to continue this application problems. So see you in a while. Please, I want you to watch the second video. It will be part 2 of vectors.